Welcome back to another lecture from organic chemistry. In last lecture, we went through this example, and so we said we have one tertiary butyl 4-methyl group that they are attached to cyclohexane. The tertiary butyl is bulkier than methyl group, so we said if you have to choose, then put the tertiary butyl inside the equatorial position. If you have to choose, and then the methyl in axial position, because the third butyl is bulkier. But if you have option for both of them to put them in equatorial, that's going to be the best condition. So this is a position of the third butyl and the methyl on the cyclohexane. As you see, the third butyl is pointing down, but in the equatorial position, while the methyl group is pointing up in equatorial position. So one group is pointing down, and the second one is pointing up. Okay. And we said the correct answer in this case, C is going to be the correct answer because both of them are in equatorial position. What's the worst structure? The worst structure when you have both of them in axial position, and B, it will be the worst one. Why? Because we're gonna see 1,3 diaxial strain between the third butyl and axial hydrogen atoms that they are pointing up, and also another 1,3 diaxial strain between the methyl and two hydrogens that they are pointing down. And as you see, we have huge strain, 1,3 diaxial strain between the methyl and hydrogen and tertiary butyl group and hydrogen atoms. Okay, now I want to introduce a new term that we call cis versus trans. When do we say two substituents are in a cis position or axial or trans position? If both groups are pointing in the same direction, okay, same direction, that time we say they are in cis conformation. Okay, and so for example, in this case, we have the methyl is pointing down. The second methyl also is pointing down. Okay, so I'm going to say these two are in a cis, okay, cis conformation. Okay, again, they can be both pointing down or both up. So if both of them are pointing up, that one also is going to give us cis conformation. But if one of them is pointing up and the second one is down, okay, in that case, we say we are dealing with trans structure. Okay, let's practice some example. Okay, the first example, we have a methyl. This is methyl. So okay, you can say I have CH3 here, and that one is CH3 as well. Okay, and usually we just simply show them by a line. That means you're dealing with methyl group. Okay, so one line is equal to CH3, or you can simply say Me, which is equal to CH3. Okay, again, this one is equal to CH3. Okay, so one of them, okay, this one is pointing up, and the second one is pointing down. They are in opposite direction, so I'm going to say I'm dealing with trans. Okay, next one. This one is pointing down. How about the chlorine? Also, chlorine is pointing down. Why chlorine is pointing down? Okay, let's show the hydrogen atom. Okay, starting from the iodine. Iodine is pointing down. So here I'm going to have one substituent, and that's going to be hydrogen. Okay, hydrogen, it will be pointing up, here down. This one is up. So hydrogen is going to take the axial position. That means the chlorine is going to take the equatorial position, and it will be pointing down. And because it's pointing down, both of them are pointing down, I'm going to say this is going to be cis structure. Okay. Next, we have the third butyl is pointing up. And how about the methyl group? Okay, let's figure it. If the third butyl is pointing up, then this one will be down. Hydrogen here, it will be in axial position, but pointing down. This one is going to be up, and the axial position, it will be down here. Okay, so this is equatorial position, but it's pointing up. So it's going to be, this one is going to be equatorial position, but it's pointing up. Well, this is the third butyl is axial position, and it's pointing up. Okay, because both of them are pointing up, this one, it will be cis. Okay. The bromine is pointing down. Okay, how do I know it? Okay, how do I know it? Because because axial position, it will be here. Okay, that's the axial position. So up, down, up, down. So what's the position of the bromine? Bromine, it will be up. Okay, so I'm going to say this one is up, one is down, one is up. This is going to be a trans. Okay, another one. Okay, we have chlorine that is pointing down. So let's say this one is down. Okay, if this one is down, the next axial position, it will be here. That means this chlorine also, it will be pointing down, but is in equatorial position. Okay, the thing that I'm looking for it is I want to just know which direction is pointing. Okay, this one is again, it's pointing down. So I'm going to say these two are cis and cis position. Or sorry, cis structures. Structure. Okay, how about the methyls? Okay, methyl versus ethyl. Methyl is pointing down. Okay, if methyl is pointing down, okay, this is going to be the axial position is pointing up, then down, up. This one is down. Okay, so that one is down. Okay. Well, the methyl also, methyl was also down. Both of them are pointing down. So I'm going to be dealing with two substituents that they're pointing same direction. I'm going to say this is a cis structure. Okay. When it comes to cyclohexane, we said the best structure for it is the chair conformation. But the chair conformation, it can actually flip to another form. Okay. And what I mean by another form, so if you highlight this region, okay, this one, okay, as you see, the slope here, slope is positive. Okay, the slope is positive. Well, this one, this region, slope is negative. Okay, now, okay, so the slope there is negative because that group is that, you know, that line is pointing down. Okay, so I'm going to say the slope here is negative. Okay, this, you know, like movement from a positive slope to negative slope, we call it ring flip. Okay, ring flip. Whenever you're dealing with ring flip, the axial position, it will switch to equatorial position, or equatorial, it will turn to axial position. Okay, but one thing that you have to keep it in your mind, if they are pointing up, if that substituent is pointing up, it will be pointing up regardless of whether it's taking axial or equatorial position. So I'm going to say the methyl group is pointing up. Okay, the methyl group is pointing up and hydrogen is down. Okay, now the methyl group is in axial position, so I'm going to say methyl group is axial position and it's pointing up. Okay, I don't care about the hydrogen. Let's talk about just the methyl substituent. Okay, when you do ring flip, the axial, it will turn to equatorial. So I'm going to show the equatorial position. The equatorial position, it will be here. Okay, this is equatorial position, and that's going to be CH3. CH3 is pointing up. Where is the methyl? Where is the hydrogen? Hydrogen, it will be here. Okay, hydrogen, it will be pointing down. Remember, hydrogen was equatorial and is pointing down. Now, hydrogen is axial, but still is pointing down. Okay, how about the methyl? Methyl was axial, now is equatorial, but is pointing up. Okay, another example. Okay, we have methyl that's in equatorial, but is pointing down. And hydrogen is axial position, but is pointing up. Okay, we're going to do ring flip. And in that case, the equatorial methyl substituent, it will turn to axial. Okay, where is the axial? The axial is going to be here. Axial, it will be pointing down. Okay, this is the axial. And we will have CH3. So CH3 is going to have axial position, but is pointing down. And where is the hydrogen? Hydrogen from axial, it will get equatorial position. So that's going to be hydrogen. Okay, and hydrogen has axial position, sorry, equatorial position. So from axial, we move to equatorial, but it still is pointing up. So let's highlight, okay, let's highlight axial and equatorial. Okay, methyl, we started axial, we got it, equatorial. It was up and still is up. Okay, how about second example? Methyl was equatorial. Okay, now is axial. Used to be here, like it was pointing down, and it still is pointing down. Okay, so up, up, or down, down is not going to change. Okay, it's not going to change. But equatorial is switching to the axial is switching to equatorial, and equatorial is switching to axial. So keep this one in your mind. Okay, whenever we are doing ring flip, the axial it will change to equatorial, and equatorial also can turn to axial. So that means we do have equilibrium. Okay, we do have equilibrium there. Okay, which one is dominant depends to repulsion that you have, the strain that you are dealing with. So it's okay. It's better to write double arrows that to show that we are dealing with equilibriums. Okay, and that's the reason we call it, ring flip equilibrium. Okay, so we have a methyl group here, and the methyl group, I'm going to assign the position for it is axial and is pointing up. I'm going to do ring flip, and in that case, methyl from axial, it will turn to equatorial. Where is the equatorial position? The equatorial position is going to be here, and that's going to be CH3. Okay, and check this. Okay, from axial, it's going to turn to equatorial, but still is pointing up. Still is pointing up. So up stayed up, but the axial turned to equatorial. Okay, so keep this one in your mind that up is gonna up stay up, and down is gonna stay down. Okay, we do not mess with the direction whenever we do ring flipping. And this is going to be end of the chapter. I do have some example. Okay, and okay, one example here we have ring flip. Okay, and so for example, this bromine is in axial position and is up. That bromine in axial position and is okay, and is pointing down. First of all, I want to know whether it's a cis or trans. Okay, one of them is up and the second one is down, so I'm dealing with trans. Okay, and if you do ring flip, okay, in that case, okay, one of the bromine, it will go down from axial, it will go to equatorial position, and that bromine, it will be here. Okay, called bromine number 1, and that bromine now is in equatorial, but still is pointing up. Okay, on the second carbon, I'm going to have another bromine. Bromine used to be axial, now I need it to be in equatorial position, and the equatorial position, I will, equatorial position will be pointing down, and I'm going to draw it in this direction. So this is going to be another bromine, and bromine in this position is in equatorial, but it's pointing down. Okay. The terbidiol is up, the methyl, and then the axial position, and the CH3 is in equatorial position. Okay, if I want to do ring flip, in this case, the terbidiol from axial that is pointing up, it will go to equatorial that still is pointing up. Let's draw the equatorial. This is the terbidiol. Okay, 3 carbons far from it. We need to have the methyl group. So I'm going to say 1, 2, 3 carbons far from it. The methyl, okay, used to be in equatorial, but it's pointing down. Now it's going to be in axial position. Okay, axial position that is pointing down, and I'm gonna put the methyl group here. And this is gonna be CH3. Okay, CH3 now is in axial position that is pointing down. And the third butyl is in equatorial, but is pointing up. Okay, one is up and the second one is down. So this is gonna be trans.